Alrighty folks, welcome back. So we're gonna get right into things, and yes, I'm gonna be trying to do these daily so that we can quickly get through stuff because I'm actually excited to try to tackle a little project like this. So last time we ended, I was going over some loops. We went over for each and I said this right here looks scary, but it's not really that complicated. So let's break it down into its basic parts. So when we have a for loop, we have three different parts to it. You're going to have for, and then we're going to have the initial statement. I'll just say initial here. And this is run once. Once to start. You can put literally anything in these. The most commonly you're going to see int I equals 0 or int something equals 0, setting an integer to 0. There's a reason for that, but we'll get into that. So you have your initial statement, and then you have your conditional statement, which, to be simple, is if true, continue. Whenever that second statement is true, it's going to continue looping, all right? The moment that it isn't true, it will not loop again. And then you have the action that is taken afterwards, right? After. So now that we have our initial statement, the conditional, and action, and then we have our brackets that show what is actually being run. Remember, like I said before, brackets just show what is contained within something. They're very useful for formatting, and your IDE will put tabs in so everything looks beautiful. All right, so this is basically going to do the following. We have the initial statement is int I equals 0. What's nice is we already know what this is because we talked about this before. When we do string lines equals new string array, we already talked about what that is. We're creating a variable that is a string array called lines, and it is equal to this. So what is this doing? We're making an integer variable called I and setting it to 0. So int I equals 0 means that there is a variable named I that is now equal to 0, and it is an integer. If you don't know what an integer is, it's a number that doesn't have a decimal point. All right, so then we have, I'll actually draw a little arrow here so that you understand that's that. So now we have our conditional. What is our conditional here? Our conditional is fantastic. I have a spam call. Our conditional is I is less than lines.length. Lines.length is going to get lines here, and it's going to get the length of the array, which we know is 1, 2, 3, 4, right? So lines.length, which I'll write right here, is actually 4. So while this is true, it will continue running. When is this true? When I is less than 4. If I is starting at 0 and it runs until it's less than, while it's less than 4, then we know it's gonna run 4 times. And how is it going to eventually end? Well, because this here, I++ at the end, which actually should not have a semicolon at the end. Made a little mistake there. This last action here, ++ means to increment by 1, right? So after we go down here, once again, loop, we got I++. And now we can actually simulate the entire thing running and what'll happen. So let's start. We'll make a little table down here showing what happens. So I equals 0, right? It runs the code because it is less than, so 0 is less than 4. That's true. I++, fantastic. So now I equals 1. 1 is less than 4. Great, it runs whatever's in the brackets. I plus plus. I equals 2. 2 is less than 4. Great, it runs the code in the brackets. I plus plus. I is 3. 3 is less than 4. It runs the code in the brackets. I plus plus. Now I is equal to 4. Oh, what did my screen turn off? Oh, am I not? Oh my god, I think my iPad died. Well, that's unfortunate. We may have to go iPadless. That was not planned, but that's not the end of the world because I think I got the concept across anyways, right? We've got, once it hits 4, it is no longer less than 4, it is equal to 4, and that means that it's going to stop. So how many times does it run? 4 times, because there are 4 things here. There are different times, different magical things we can do with this, but that is the simple for loop. You have 3 statements. Your initial statement, your condition, and then the action that's taken afterwards. Very simple. So we can go ahead and we can actually do console.writeLine. I'm going to just say again, console. There's only one console we access, so there's only one WriteLine method, so it's static. We don't need a specific console. We can just call it directly from console. And we can, instead of just writing the line, let's go ahead and do the line and the number so that we can see what I is. So there's 2 ways we can do this. I could just do I plus and then a space plus line, or lines I, because we're getting the ith line. So if it's line 0, it's going to get this. If it's lines 1, it's going to get this. If it's lines 2, it's going to get this, and so on. But because I don't want to give you guys like bad info, I'm going to tell you there's a far easier way to do this. Much cleaner nowadays. It's string interpolation, and what we can do is we can put a money sign and then the quotes, and now anything you put inside of squiggly braces will get just turned into strings on the fly. So we can actually put the line number inside of there, put a colon, and then we can do lines I. So like I said, it'll inject whatever is inside of squiggly braces into the string. So when we do this, anything that is brown is just going to be the string itself, and then these are going to get injected in. So we get the I, which is injected into the string, and then we get whatever line is at I and inject it into the string. And now if we go ahead and run this, let's turn off that camera. If we go ahead and run this, you are going to see that it works exactly how we would expect. Notice how, like I said, we have the brackets, which are always there, and then the I has been injected into that string, and then the line at the ith index has also been injected properly. It's very nice. And you'll also notice this happened 2 times. What is this? Well, this is this first one we did here. So we have the for each, which runs. Then we have this one that runs. You may be saying, well, how would I get the number for the for each? You could, if you really wanted to, do int I equals 0, and then remember at the end of for each to just do I++. And then that would basically be equivalent to this. But for each, if you're using the I, you might want to just use a for loop. It's up to you. It's a lot of things come down to specific programmers and what they enjoy. I'm simplifying things a lot. I do actually know how to program pretty darn well. It's just I'm trying to be simple. I'm glossing over things that are bound to confuse you until we really have to talk about it. But there's a few more loops. So there's the while loop. A while loop is very powerful. It is a very powerful thing that you can use very incorrectly. Because the for loop, generally, since you're defining this right here and you have a start already and you're incrementing, generally, if you use the for loop the way that it's usually used, you're not going to have it run forever. The while loop is pretty easy to make run forever. Actually, I can do while true, and this will run forever, as quickly as my computer can do it. You can't really, I guess you could do like for bool b equals true, b, and then just don't do anything, but that would be weird. There would be no reason you might as well just use a while loop at that point, and that's why while loops can be a little bit tricky, because if it never turns false, then But we can go ahead and do, for example, int I equals 0, and we can do while I is less than lines.length, I++, and do this again. Again, pretty much equivalent. You're gonna notice this is angry. It's because if I'm defining I here and I'm defining I here, I can't define I multiple times. So I'd have to call this like K. I, K, and J are very common to be used for this. That's what you're gonna see most often. So if we go ahead, you're going to see this is going to run pretty much the same as this. Again, there's different things that would be arguably cleaner to run than other things. I did actually not screw that up, right? Why didn't that show up how I expected it to? Oh, there it goes, yeah. So, literally the same. The point I'm making is that with loops, you can do a lot of different things. Now, there's another kind of loop, which is actually pretty useful. Say I want to do something once, and then I want to keep doing it until something is false. Because, like, this, sometimes you have a while loop where you want to do something one time and then check, rather than have the check beforehand. An example of when I have personally used this is if I'm making a call to a website, right? I'm trying to get a resource from a website. Well, I always need to do that at least once. Now, if it fails, I continue trying. So, for example, let's say we did like bool success, right? So this is whether or not it was successful to get it from the website. So I would do like do. So this is the first time we do it, and then we do like success. This needs to be defined beforehand. Things go in order. So success equals true, while success equals false. Or fun fact, if you want to invert, you just use an exclamation point. Exclamation point success is the same as saying success equals false. Another thing I should say right out the bat is double equals and equals are different. Equals means a sign, make something equal to something. Double equals is checking if things are the same. Very similarly, and are the same, aren't the same, but we'll talk about that in a bit. So, while success is false, it'll keep running whatever is in here, but this, obviously this would be useless because this is immediately setting success to true, so this would never run. But if, for example, success equaled something that we aren't sure about, so let's say like, go get resource from website, and I actually did this wrong. This should have a semicolon at the end there. So basically, what this is going to do is we have bool success. So we do run it once. Success equals go get resource from website. If it didn't work, if it wasn't successful, it'll do it again. And if it wasn't successful, it'll do it again. If it wasn't successful, it'll do it again. You won't really use this too often, but it can clean things up a lot compared to... The alternative would be to... Let's go back. The alternative would be you'd have to do like success equals go get resource from website, and then while not success, again, you have to do this. This is repetitive. If you find yourself repeating something twice like this, you're generally doing something wrong. And in code, you should not be doing the same thing over and over. If you're doing the same thing over and over, you should be able to turn it into some kind of loop that'll make it into one repeated thing rather than you having to write it out over and over, all right? If you're writing something out over and over, that is generally a sign you're doing something horribly wrong. But let's go ahead and actually do something of value now. Let's do our first step in making a game, because now that we know how to make a loop, how to do simple stuff, we can take a big step. I'm going to delete all of this, and we're going to draw the square that our game is going to take place in. And we're going to create a method for this, right? I'm going to create a method. I'm going to call it public, static, because there's only one, void, because it's returning literally nothing, and I'm going to call it draw, because it's going to draw the game. We don't need to send anything into it right now, because we're just going to make it real simple. In main, we're going to call draw once, so that when we play the game, it'll draw once. Obviously, later it's going to have to draw multiple times because your game has more than one frame in it. But let's go ahead and draw a grid. Now, if you are mathematically capable and know a little bit about math, thankfully the iPad is charged enough for me to actually draw this out. I was trying to stall a little bit there. All right, let's go ahead to the code split screen, which hopefully will get signal in a moment if we're lucky. Come on, baby, there we go. All right, so let's start out by choosing how big of a grid we want it to be. Up here, inside of the class, if we define things inside of the class, anything within that class will be able to access it. We're going to make some constants, which means things that never change. And we've already defined a variable before, so this shouldn't be crazy. We're going to write const, which means it never changes. Constant int, which means a number without a decimal. Constant int, and we're going to call it size x. And we'll make it a nice, pretty number, 32. And then similarly, constant int size. It's actually going to predict what I'm going to do because this is pretty simple. So 32 by 32. Constant int size x equals 32. Constant int size y equals 32. It is a constant. It does not change. It is an integer. It is size called size x, and it is equal to 32. If we want other things to be able to access this, which we will, because the size of the game is going to be important to other things at some point, we're going to put public at the beginning. And now watch this. Because it's public, anywhere I want, I can do program dot size x to access that. And because it is a constant, the program knows if you hover over, it is equal to 32. Brilliant. So now within draw, I'm going to draw this on the iPad, how this works. So we want a grid that is 32 by 32. This is going to be Y. In computers, usually your up-down axis is going to be Y, unless you're using AutoCAD like Blender, where that'll be Z, but if we're working in 2 dimensions, Z doesn't even exist. So let's not worry about that. We're going to have Y, and we're going to have X, right? Or 2 directions. More generally, you will see it drawn kind of the opposite. I don't know what I'm doing here. I mean, if you've ever drawn a graph before for school, you should know the XY coordinates. And we're going to have it be 32 by 32. For now, let's just fill it with dots. So we're going to have 32 dots by 32 dots, right? I'm not going to draw it out the whole way because that'll take a bit. We can break this down. In code, a ton of things are about breaking things down. We know how to make one line of text because we have done it before. Right line, right? So let's go ahead and we will, for now, just get a grid out by making a bunch of rows. And if we do a bunch of rows in a row, we should get a full square. So how are we going to do this? If we want to do something 32 times in a row, you're probably thinking, well, if we want to do a specific number of times, that sounds like a for loop to me. For int x equals 0, x is less than size x, which is right here. It's defined, so we can use it. X++, so it increments each time. So, brilliant. Very nice. And then, this is going to be the rows. This will make one row. And then we want to do that 32 times for y. For y equals 0. Y is less than size y. Y++. Great. So, for every single x, we want to add a single dot. We don't want to write a full line. We just want to write one dot. Thankfully, we can do console.write a dot. Notice how I'm using the single here and not the double quotes. That's because this is a character and not a string. There's only one. A single letter, number, or symbol is called a character. A string is called a string because it is a string of characters. Notice how if I put 2 dots, it's going to yell at me because that is not a character. You could do this, but technically, if you only have one, just use a character because optimization. I don't know if it'll automatically convert it. The compiler's probably smart enough, but good habit, know what you're doing. So for 32, this will do that. It'll write a full line. Now, after that line is done, right? Okay, so let me think. Actually, this is going to run... I'm going to invert this. There's a reason for this, because we have to think logically about how this is running, right? Because this runs first. Kind of. Let me explain. Let me explain. Okay. So I've inversed these. So y, size y, y++, x, size x, x++. The reason I said that is because this runs after this. This runs 32 times in a row, and then this runs once, and then this runs 32 times in a row, and this runs once. Do you understand what I'm saying? This will also run 32 times, but for the smaller increments, because this shifts a whole line down, this shifts one to the right. So I'm just flipping it. It makes more sense to me. It would technically work either way. Well, no, this would still have to be here. But so for 32 times, this is going to write a dot. After those 32 times, we shift down one for y. So we're gonna write line, or we're gonna write, and we're gonna write \n. What is that? \n is a new line, so that's going to add a new line. So let's think about how this is gonna run. So we're starting y at 0. Now we are going to 32 times write a dot. And then we're going to add a new line. Then y is going to be 1. Now we are going to 32 times write a dot. Now we are going to add a new line. This is going to start at the top left and it's going to write down to the bottom right. So that is something we're going to have to keep in mind. Our numbering is going to be a little bit weird, and we could actually, once again, change this to make more sense. If you look at the iPad screen, I will explain, because if we're writing into a console, so if this is our console here, it's going to write the dots like this, you know, in the order of text. And we would expect it to be the opposite, because this would be 0 going down to 32, and same this way to 32. Now, this is expected on the left to right, that it would be going up to the right, but going down, going up, that's kind of weird. So what we'll do is we'll do int y equals 32, y is greater than or equal to 0, y minus minus. What does this mean? Well, we're starting y at 32. So now instead of this going 0 to 32, we are going 32 to 0 and 0 to 32. Y is greater than or equal to 0. So if we think about logically, greater than or equal to 0 means it can't go under 0. Y minus minus means it decreases each time. It's basically the opposite of this. And actually, this shouldn't be y equals 32. We should use our size y here. Brilliant. Okay, so now that everything makes logical sense, I am going to bet you that this will work. Let's go ahead and hit play and see if we get a grid of 32 dots. And would you look at that? We have a grid of 32 dots by 32 dots. Now, I do have a slight issue with this, which is that it's not spaced out evenly. The space up and down between the dots would appear to be far greater than the space side to side between the dots. If we go ahead and change this to make it like 5 by 5, we can make sure that it is actually 5 by 5. 5, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Why are we getting 6? That's a good question. Let's figure out where I messed up. I see where I messed up. 0 to 32 is actually 33 different numbers. So we need to do y equals size y minus 1. Great. Hit play. 5 by 5. Brilliant. Now, the question becomes, how do we get the line spacing to be equal? And this is where I'm going to consult Google. Windows console equal, change line height, change line height. I'm curious about this. Although we could also just try to change this, and we could do space dot space. I feel like that's going to be too wide, though. Actually, that's pretty evenly spaced out. I'm kind of surprised by that. If I did this with just a single, that's pretty reasonable as well. I think that'll work. So if we wanted it to look solid, like there's material there and we did a hashtag. Yeah, that's workable. All right, so let's go ahead and set this back to 32 by 32 and see how this looks. All right, so we got a big old grid, but it's at least consistent. This is pretty square looking. And if this is where our game is going to be played, brilliant. Cool, so we have a grid. Is that super exciting? No, but this is opening the path. We're going to kind of make the sort of game that you would make on a graphing calculator here. So we have a good start. So we went over loops this time, a few different kinds of loops. We have practically used the loops. And we've learned how to do a little bit of spatial geometry, which is exciting. Before I go, I just want to go once again over how this works because I want you to understand it. So let's go and start from the beginning. So we have our method called main. Main is called by the OS, actually, so that would be Windows in my case. The OS calls main. Main is calling draw. Draw has a for loop, which is going to start with y equaling 31 until y equals 0. 0 through 31 is actually 32 different numbers because we are including 0, right? Then the same way, we have for x equals 0 to x equals 32. For every single one of these, we are going to make a dot. And for every single one of these, we're going to shift down a line. What does this look like in reality? It looks a lot like this. We have our x-axis, our y-axis. We're starting up at 32. And 0, this is 32 for the x. Goes this way, this way. So we're writing our dots like this, shift. Writing our dots like this, shift. Writing our dots like this, all the way until we get to the very bottom. Got it? Seems simple. Doesn't seem too complicated. Just remember a few basic ideas. We've introduced initial, condition, increment, or honestly, whatever action you wanted to call after the after each step of the loop. Remember, this is run after this is called. That's another thing you should remember. But other than that, there we go. We've drawn a grid. It's very exciting. I cannot believe I have spent almost a half hour on that, but I'm trying to make things explicitly clear. So there you go. You've made a grid. It's exciting. Next time, we're going to make different types of materials to put in the grid, and we'll start drawing things that are a little bit more exciting. Cool.